Hi there. In this video, I'm going to go over a few simple examples of how to solve for a variable. Okay, so a quick refresher, a variable is a number that can vary, can change. All right, so that's why you see a letter there, because let's say you're given a function that you graph, you're going to input a whole bunch of values, so those values are always changing. So they're varying, and that's why it's called a variable. Use the same word variable, even if it's just an equation that you're not really going to graph per se. Like you don't see an x and a y variable in this equation. You just see an x variable. But if you don't know what number should go there, that's why you use a letter. Okay, so here I have x plus 6 equals 10. And you might be able to do this in your head, but if you don't know how to do it using algebra, then you need to keep watching, okay? Because what number plus 6 equals 10? I know 6 plus 4 equals 10. And so that'll help me, kind of mentally check my answer. So the best way to think about these kind of algebra problems is to picture you're on a scale or a seesaw, okay? So this is my seesaw, and I have some number, and I'm gonna call it, I'm just gonna put a question mark. You don't know what it is. Plus 6 things, and then you got 10 things over here, okay? So if I just take away these 6 things, now my scales are going to be, well, this side will just be heavier. It'll look like that. All right? But so you can't just take something away. All right? It has to be justified. I have to use both sides of the scale, because if you add or subtract one thing on a scale, well, you got to do something to the other side of the scale to keep it balanced. Okay? So if I am adding 6, let me rewrite plus 6. If I'm adding 6, this balance point will be my equals. Something plus 6 equals 10. All right? If I want to get it to the opposite side of the scale, I'm going to do the opposite operation. So that cancels out because 6 minus 6 equals 0. All right? So I have question mark, or x, equals, what's 10 minus 6? 4. Okay, so in other words, I'll just say x equals 4. All right, so I did that to both sides to keep both sides of my scale even. All right, so what you do to one side, you have to do to the other side. So let's do a slightly more complex example. Let's say like 2x plus 7 equals negative 13. All right. So if I were to go back to drawing this on a scale or a seesaw, all right, I have 2x plus 7 equals negative 13. Okay, so remember that balance point is where the equal sign goes. All right, so if I want to, the key to remember is you want to move all the numbers that are on the side with the x, because the final answer needs to say x equals something. Okay, so I see this negative 13, and when I'm with my students, a lot of times they see a negative number and they're like, oh, plus 13. Sure, you could plus 13 to the other side, but then you'd have nothing left over on that side, and so why bother with it? All right, if it's not on a side with a variable, then it's on the side it should be on, so just leave it alone. So right now I'm going to look at the 2 or the plus 7. So you want to look at for the numbers that you can add or subtract. That's always the first step you should do. So if I see a number that's plusing 7, I'm going to minus 7 to the other side because it's going to go to the opposite side. So I'm going to minus 7 to both sides. And that'll cancel out on the left side. And then since it went to both sides, it stays balanced, okay? The scales haven't been tipped. I'm just going to rewrite this as 2x equals negative 13 minus 7, so negative 20. Okay, so how do you get rid of the 2 by the x? Well, first let's just talk real quickly about what 2x even means. Anytime you see a number written right next to a variable, it always means multiplication. You don't see a little plus or minus sign in between there, so it's always multiplication. Anytime you see two things written next to each other, multiplication is always implied. So all this is saying is 2 times x. And it's a good idea to, use a dot to show multiplication whenever you're showing it, unless you're writing it together like 2x. Because, if you're using variables, especially x as your variable, and you're putting the x symbol for multiplication, then things would just get confusing. So that's why we just use dots, okay? So just to reiterate, 2x means 2 times x. So it gets kind of confusing with this balancing of the scales thing when you're talking about adding and, multiplying or dividing. So just think, I'm sending it to the opposite side of the scale, so I need to do the opposite operation to keep things balanced. So what's opposite of 2 times x? The opposite of that would be to divide by 2. So I'm going to divide both sides by 2. And anything divided by itself cancels. It leaves you with 1. So 2 divided by 2 is 1. So I have 1x equals negative 10. All right, but you don't have to write the 1. All right, the most common incorrect answer right here is that x equals 1. No, if you just see an x there, that means you have 1x there. Okay, it just means there's 1x present. Doesn't mean x equals 1. Those are completely different meanings. Okay, so here x equals negative 10. Okay, or 1x equals it, but again, you don't have to put a 1 in front of it. It's understood. I'm looking at 1x currently. All right. Let's do one more example here. And let's use a fraction, okay? So here I'm going to have 5 over 3x minus 7 equals negative 2. So here I'm using a couple extra negative numbers just to make things maybe more confusing, but really the same level of the difficulty level never really goes up. Okay, so here I have my equal sign. That's my balance point. Okay, so on this side of the seesaw on the left side is the x. So on the right side is a negative 2. So I'm just leaving the negative 2 alone. Okay, look how beautiful my seesaw looks. It looks like it's bending under the pressure of the weight. But so what I'm going to do here is I'm just going to rewrite this equation because I made that one look not nice. Another thing you might see is instead of having to try and draw a seesaw each time, just draw a line down the equal sign. And so that way you're splitting up the two sides. You're definitely moving something over to the other side. So look for a number that's adding or subtracting next to the x. So this is minus 7, so that means I'm going to plus 7. And so here I have 5 over 3x equals negative 2 plus 7 is 5. Now, how do you get rid of a fraction? Well, remember, this is 5 over 3 times x. So you could divide by 5 over 3. If you do that, make sure you use parentheses. Chances are you're using a graphing calculator. So anytime you're using fractions, it's always a good idea to use parentheses. That's correct. This is correct. But the easier way, and I can do a separate video to go into a bit more detail, is to just flip it and multiply. So if I have 5 over 3x equals, it was 5. The opposite thing would be to multiply by the opposite of the fraction, okay? That's the same exact thing by dividing by the fraction in its regular form, okay? So this will cancel out, all right? And that'll just leave me behind with an x equals, and this is just going to equal, it'll equal 3. So whatever your preferred way is, you'll see more math teachers and mathematicians do this second way that I showed you versus this way. But this still shows me you understand how to do it, okay? It's still correct. 5 over 3 is a number, so if you have a number times x and you divide that number to the other side, it still works. Again, just use parentheses. So that's it for the solving for variable examples. Stay tuned for our additional videos. Thanks. Bye.